Hello and welcome back. In section 6.3, we're going to, at least for now, skip over the applications in 6.2. In 6.3, we get to work with integration by parts. So integration by parts is a relative of our friend the product rule from previous coursework. Previous work in this course, I should say. So if you'll recall that the derivative with respect to x of f of x times g of x, we took the derivative of f of x, multiplied it by g of x as it was, and added that to keeping f of x and differentiating g of x. So differentiate one, keep the other, trade roles. So what we do is a little bit of rearranging, and we're going to get this part by itself. So we can say equivalently f of x times g prime of x is worth the derivative with respect to x of f of x times g of x. And we would have subtracted f prime of x, g of x from both sides. So what we can do from there is integrate all three pieces of that. So we'll take the integral of f of x, g prime of x times dx, and that's going to equal the integral of the derivative with respect to x of f of x, g of x times dx minus the integral of f prime of x, g of x, also times dx. So this far left-hand side, I'm just going to bring that down as is for the moment. Integral of f of x, g prime of x times dx. This one, integral and derivative are inverse operations. One is undoing the other. This would basically free us to just pull the f of x, g of x, minus integral of f prime of x, g of x times dx. Now, technically, we could use it this way. There's a much more commonly used shorthand for this. So f of x we label as u. G prime of x times dx, we call that our dv. So f of x is still the u. If dv is g prime times dx, then g of x would be v itself. F prime of x, that would be du then. F prime of x dx is du. And g of x again is v. So the integral of u dv is equal to u times v minus the integral of v times du. Write that down as many times as you need to so that you get to know it. Integral of u times dv is uv minus integral of v times du. So basically, when we start the problem, we'll pick out what we want to label as u, what we want to label as dv, and go from there, figuring out the rest of the pieces of the puzzle. So where we would use this, for example, if we have the integral of x e to the x times dx, this is one that we couldn't use just a single u substitution. We would have to break it into two pieces. So for this one, we'll let u equal x, and we'll let dv equal e to the x times dx. So those two we have, and the other two we find. So du here would be dx, and v would be the integral of dv, so that would be still e to the x. So the two in black we have, the two in red we find. So now we can say that this is u times v, so x times e to the x minus integral of v times du. So e to the x times dx. Now notice what that did for us. Now that gave us a much simpler integral. So I'll hang on to this x e to the x. Antiderivative of e to the x is e to the x plus c. And that's our integral for x e to the x dx. Now if you want to convince yourself that I'm right, you can go ahead and pause it. We're not going to run through this together. You can go ahead and pause it and differentiate this. Use the product rule on this guy, find the derivative of that guy, and when you combine your like terms, you should come up with x e to the x when you're done. So this is basically sort of undoing the product rule. Alright, so next up, we'll look at the integral of 20 times x natural log of x times dx. So here we're going to take a look at how some of these are going to end up as sort of trial and error on how to start. If I tried to say, okay, let's let u equal 20x, dv equal natural log of x times dx, I can find du just fine. Du would be 20 times dx, but v, integral of natural log of x, not easy to find. Possible, but not easy. So when that's the case, if you run into something that is difficult to integrate, try trading what you've labeled them as. So since this one would be a little more challenging, switch. So this time we're going to try out u equals the natural log of x, and dv will be the rest of it, the 20 times x times dx. So du here, derivative of natural log of x, 1 over x times dx. And v, the antiderivative of 20x, x to the first is now x squared. To get a 20 there, I would have a 10 out front. We'll choose our plus c to be 0 at the moment. So now we have u times v. Just to not get confused, what is an argument versus what is a factor, I'll put the 10x squared out front. So 10x squared natural log of x minus integral of v times du. So 10x squared times 1 over x times dx. So we have a little bit of cleanup we can do on there. So I'll hang on to my 10x squared natural log of x, hang on to my minus and my integral, and this will turn into 10x times dx. And then we're just doing this antiderivative. So 10x squared natural log x, still along for the ride, minus. So we would have 10 times 1/2 x squared plus c. So our antiderivative would be 10 x squared natural log of x minus 5x squared plus arbitrary constant c. All right, so we have, you try a couple out. So one from me, one from your author. So we'll try out integral of 5 natural log of x times dx. And when you finish that one, try out integral of x natural log of 2x times dx. So go ahead and pause it. Use the integration by parts. Okay, welcome back. So we saw in the previous example that natural log of x doesn't have a fast, easy antiderivative. So we'll make that part our u, which means our dv will be 5 times dx. So du, 1 over x times dx, and our v, antiderivative of a linear, or of a constant, is a linear. So we have u times v. So I'll shuffle the order and call it 5x natural log x, just so it's clear that 5x is not part of the argument of the logarithm. uv minus integral of v times du, 5x times 1 over x times dx. So this would be 5x natural log of x minus integral of 5 dx. So 5x natural log of x minus 5x plus c would be our antiderivative. So our next one, again, natural log is not easy to integrate in a single step. So typically we will make that part of our u. Our dv for that problem would then be x times dx. So our du, so u prime over u, so 2 over the 2x, which is 1 over x. So notice that should fit with what we would expect to see on there if we had expanded that. Not that we would have to do it this way, but recall natural log of 2x is natural log of 2 plus natural log of x, since it's the log of a product. Natural log of 2 is just a constant. Derivative of a constant is 0. That would drop off. Derivative of natural log of x, 1 over x. And our v then would be half x squared. So then u times v again, half x squared natural log of 2x minus integral of v times du, half times x squared times 1 over x times dx. Almost forgot my dx there. We do need that. So a little cleanup, half x squared natural log of 2x minus integral of half x dx. So x squared times 1 over x. So hang on to the part we already figured out. Half x squared natural log of 2x minus half antiderivative of x would be half x squared and a plus c. So this one is there because it was already there. This one is there because we were integrating x. So we'd have half x squared natural log of 2x minus a quarter of x squared plus c. Okay, so our next at-bat, we're going to see what happens if sometimes we have to repeat the process. We'll do integral of x cubed e to the x times dx. So our u will make that the polynomial part, dv will make the e part, so e to the x times dx. Okay, we'll get another one. There we go. So our du, that would be a 3x squared times dx. And our v for this is just e to the x. So now we have u times v, so x cubed e to the x minus integral of v times du. So 3x squared e to the x dx. This one I can't do it with one single round of u substitution. I'll need integration by parts again. So this much is just sort of along for the ride. We're going to keep it on each step. And then we'll do another little mini problem setting up our u and our dv again. So our u will be the polynomial part 3x squared, dv will be e to the x times dx, and then we'll find our new du again and our new v again. So du would be 6x times dx, v would be e to the x still. So don't forget to bring along what you already had. And unlike what I just did, try to copy it correctly. All right, x cubed e to the x minus, I'm going to group all this stuff in brackets, u times v, 3x squared times e to the x, minus integral of v times du, 6x e to the x times dx, close it on up. We'll do a little bit of distributive property here to simplify. And then we'll have one more round of u substitution, u dv substitution. So notice both of these signs are flipping. So again, we'll label our u and our dv. Our u is going to be, again, the polynomial part. dv will stay as e to the x dx. So du this time is 6dx. v is e to the x. So I'm going to keep what we had before. We still have our x cubed e to the x. We have our minus 3x squared e to the x. And now we have plus u times v, 6x e to the x minus integral of v times du, 6 e to the x times dx. And we're finally at a place where I don't need any substitution to do that integral. So hanging on to the rest of it, x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus the integral of 6e to the x is 6e to the x plus c. So that's as far as we can go on that one. So you may need more than just one round of the u-dv substitution. That is quite possible. Alright. So far we've looked at indefinite integrals each time. We do also take a look at some that are definite integrals. So this one we'll look at the integral from 1 to e of 5 natural log of x times dx. So most of it is handled the same as before. So we'll pick a u, we'll pick a dv. Natural log is not easy to integrate, so typically we put that as our u and make the rest of it the dv. So du, 1 over x times dx, v would be 5x. And if x is equal to 1, u is natural log of 1, which is 0. If x is equal to e, u is natural log of e, which is a 1. So then we're going to have u times v, so 5x natural log of x. Not really necessary on here. We'll discard the extra substitution. We'll just stick with this. So 5x natural log of x minus integral of v times du. So 5x times 1 over x times dx. And we're going to eventually evaluate from x is 1 to x is e. We'll just keep it in terms of x's. All right, so a little bit of cleanup next. So 5x natural log of x minus integral of 5 dx. So x and 1 over x are going to cancel out. From x is 1 to x is e. So we have 5x natural log of x minus 5x evaluated from x is 1 to x is e. Now we're ready to do a little substitution. So we have 5e natural log of e minus 5e. And we're going to subtract off plugging in the 1. So 5 times 1, natural log of 1, minus 5 times 1. So natural log of e is 1. So we have 5e minus 5e, which is 0. Natural log of 1 is 0. And 5 minus 1 is 5. So 0 minus a negative 5 is a positive 5. Okay, so next up, maybe I'll try a couple out. Let's see, so we'll try a couple of the author's ones. We'll go from 0 to 1 of x squared e to the 2x times dx. So go ahead and give that one a spin. Unpause when you're done. Welcome back. So hopefully you remember that most of the time we've been letting the polynomial be our u and the e to a variable power be our dv. Yes, you need that dx attached. Yes, that is worth points. Du 2x times dx, same thing with that one. You do need that dx as well. And our v, 1/2 e to the 2x. So remember, if our derivative of e to the cx is ce to the cx, we would need to cancel a 2 there. So 2 by 1/2 gives us the nice pretty 1 that you see out front. So now we have u times v, so 1/2 x squared e to the 2x minus integral of v times du. So 1/2 times 2x times e to the 2x times dx. And we'll be evaluating from x is 0 to x is 1. So we'll hang on to this 1/2 x squared e to the 2x minus integral of 1/2 and 2 will cancel, so minus x e to the 2x times dx. And we're evaluating all that still between x is 0 and x is 1. So this one we did have one more round of substitution to do. So u will be our x, dv is still our e to the 2x times dx. So du was the same as dx. v once again was 1/2 e to the 2x. So we hang on to that 1/2 x squared e to the 2x minus, and then I'll group all this stuff together, u times v. So x times 1/2 e to the 2x minus integral of v times du, 1/2 e to the 2x times dx. And we're going still from 0 to 1. So a little bit more cleanup, one more antiderivative, and then we're ready to plug in our endpoints. So I'll hang on to the 1/2 x squared e to the 2x. A little distributive minus 1/2 x e to the 2x. Two negatives will flip this guy to a plus. So plus the integral of 1/2 e to the 2x times dx. We're still working from x is 0 to x is 1. All right, this one we don't need any more substitution. This is an integral we can do without substitution. So I'll hang on to the stuff we figured out before. So we already have a 1/2. And then the integral of e to the 2x is another 1/2 e to the 2x. From x is 0 to x is 1. So 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x. From x is 0 to x is 1. So plugging in our endpoints, plugging in a 1. 1 squared is 1. E to the 2 times 1 is e squared. So we'll have 1/2 e squared minus 1/2 e squared again, and plus 1/4 e squared. So that's just plugging in 1 for all these x's. Then we plug in 0. 0 squared is 0 times anything else. Doesn't matter, it'll drop to 0. But 1/4 e to the 0 is just 1/4. E to the 0 is 1. 1 times 1/4 is 1/4. All right, so we have 1/2 e squared minus 1/2 e squared. Goodbye to those. So the stuff that survives will have a 1/4 e squared and a minus 1/4. I think your author occasionally will do a decimal approximation. I'm not really interested in a decimal approximation unless it's a word problem or I specifically request one. So I do need to see the exact value of the integral. Okay, so let me have you all try one more out. Again, this is another one of your authors. Integral from 1 to 2 of natural log of 3x times dx. So you can try your substitution. Unpause it when you're done. Okay, so for this one, u will be our natural log of 3x. dv, the only thing that's left is dx. If you want to multiply by 1, you can. You don't have to. So our du, u prime over u, so 3 over 3x, which will reduce to 1 over x. We saw earlier why we know that that's going to drop out. And our v here is x. So then we have u times v, so x natural log of 3x minus integral of v times du. X times 1 over x times, what am I missing here? Our friend, the dx. So we have that to evaluate from x is 1 to x is 2. So x natural log of 3x minus integral of dx. Again, from x is 1 to x is 2. So antiderivative of, you can put a 1 here if you'd like. Integral of 1 is x. So we have x natural log of 3x minus x evaluated from x is 1 to x is 2. So we have 2 natural log of 6 minus 2. And then 1 natural log of 3 minus 1. So just a little bit of cleanup that we can do on this. 2 natural log 6 minus 2 minus natural log 3 and plus 1. And then just hit your like terms. So 2 natural log 6 minus natural log of 3 and then minus 1. And that's as far as we need to go on that one. Okay, so some problems that I would recommend trying out if you're working out of the book. This is section 6.3. I would try 9 to 12 all, 15 through 33 on the odds, and 39 to 63 every other odd. If you're interested in doing the electronic homework, send me an email and I will upload something similar that the author has. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.